Hello, welcome to today's lesson. Today we are dealing with a straight line as a function. The straight line. Now, as we have indicated, we have functions that are one to many or many to one. Some are one to one. So a straight line function is one to one. So for every one y value, there is a corresponding x value. So it's one y value, one x value. So hence a straight line is a relation that is a function. Now, without wasting any time, we are going to look at the form and the shape. The form and the shape of a straight line. Right, we have the general form of a straight line, which is y equals to mx plus c. Now, this is the general form of a straight line. Now, we are going to look at this form and also the shapes or the shape. Now, if m and c are involved, for example, if we have a line y equals to, maybe m is given that is 2 and c is given to be negative 4. So if both m and c are there, then our shape, our graph is going to be having both the intercepts. That is, it's going to cut the y-intercept probably at negative 4 and the x-intercept probably at 2. So our graph is going to cut the y-axis, the y-axis and the x-axis. So we will have both intercepts. So as long as we see the c and the m, then our graph is going to intercept the graph twice. So in other words, whenever we see that the graph is intercepted twice, for example, if I just draw the graph, you see I have the x value or intercept and the y intercept. So it means this graph has both m and c. So this function here has both m and c. So if m is there and c is there, it means the graph is going to intersect twice. It's going to have the x-intercept and the y-intercept. So now, depending on the value of m, right? So if you look at these graphs that we have drawn, this graph and this graph here, so they are both increasing functions. So we said a function increases. Remember, we are moving from the left to the right. So as we move from left to right, our graph is going up. So it means these two functions that we have drawn here, it's an increasing function. Therefore, it's definitely telling us that m is positive. So this is how we write that m is positive. So it means in both cases the m is positive. But if m is negative, for example, let's take a function where m is negative. Let's draw this one. Now it's a decreasing function. So let's say, for example, we have our function as y equals to minus 2x plus 4. So in this case, m is negative. So this is the y-intercept and this is the x-intercept. So we have this function, and now it's a decreasing function because m is now negative. So but you can see there's still the m and the c. So if m and c are there, then we will have both intercepts. So we have the y-intercept and the x-intercept as long as m and c are there. Right, so it doesn't really matter even if we draw another one here. So it has both the x-intercept and the y-intercept. So in this, both these two graphs, the m is negative, so m is less than 0. So in both graphs, you can see they are decreasing function as we move from the left to the right. The graph is going down, it's going down, it's going down. So it means it's a decreasing function. Right, so this is a form where we have both the m and the c, both the m and the c. So this is a complete form, y equals to mx plus c. Now, the second variation that I want us to look at is the situation where we don't have a c. So we will just have, this is actually the second variation. So we will have y equals to mx. Now, if we look at this one, it doesn't have a c. So whenever a straight line like this does not have a c, for example, if we look at an example, y equals to, let's say, 2x. So you see there's no plus 3 or minus 3 or whatever. So in this case, the graph, any graph that does not have a c is going to pass at the origin. So depending on m, the one that we just drawn, you can see the m is positive, so it is going to be an increasing function. So we are going to have something like this. So as long as it passes through the origin. So if m is positive like this one, so the graph will be like this. But if m is negative, so the graph will still pass at the origin, but it will be like that. So this is where m is less than 0. This is where m is more than 0. So this one m is positive, this one m is negative. But the important thing is it does not have a c. Right, so if it does not have a c, then it means it will go through the origin. So these are little things that we must learn to look at. Even before we sketch the graph or we do anything to the graph, we need to understand such little things. All right, so let's look at the situation where there is no m, right? Or we can say the m is 0. So in other words, we will have y equals to c. So in this case, it means the gradient is 0. So the gradient is 0. So now, if we have a function y equals to c, then this one, it's going to be our straight line which is parallel to the x-axis. This is the x-axis. This is the y-axis. So let's say this is our 0. Now y equals to c, depending on, remember, the c is the constant, the m is the gradient. So this constant may be any number. Let's say c maybe is 3. Like maybe we say y equals to 3. So it means the y value will be 3 somewhere here. So it means as we draw this graph, it will be a line which is parallel to the to the x-axis, cutting at 3. So this is the line y equals to c. So the gradient of this line is 0. Right, so that is the situation where we have y equals to c, where y is a constant. Now, where c is the constant. So the last scenario, it's when we have the situation where we want the graph x equals to c. Now this is also a straight line. Now this one, the gradient, like we said with that first one, the one above number 3, in this case the gradient is 0, m is 0, hence we have this. But in this case, we cannot be able to define the gradient. So the gradient is undefined. Now, what does that mean? It means, as learners, when we calculate the equation between 2 points, and we find ourselves in a situation where we are unable to define the gradient. Let me give an example. Let's say we have point A with the coordinates 3 and 5, and we have point B with the coordinates 7 and I'm sorry, let's say it's 3 and 7. Right. So we have 2 points, and we want to calculate the equation of a line between these 2 points. We want to calculate the equation. I want to write this nicely. Right. So we want to calculate the equation of a line which passes through the point A and point B. Now, we know that the first thing that we do when we calculate the equation of a line, we need to get the gradient. Now, from the previous grades, we have learned that the gradient is actually y2 minus y1 over x2 minus x1. Now, if we look at this, we can take any point to be 1, any other point to be 2. So let's say the B point is point 2, so the y value there is 7, so we will say 7 minus the y value here is 5. All right, divide by x2 will be 3 minus 3. Now, as we look at this, we realize that, okay, 7 minus 5, we know it's 2, but 3 minus 3 is 0. And now we have a situation where we have a division by 0. And we know that this cannot be defined. As long as it's division by 0, then we know it is undefined. Now, if we don't know what this fact that I'm talking about here, we will get frustrated here. We will even think that the line between point A and B is non-existent. We will think it is not there. Why? Because we are getting the gradient of 0. Not of 0, but of undefined. But then, if we go back to the Cartesian plane and try to draw this line, remember we have point A, which is 3 and 5. So in other words, x is 3. Let's say that x is 3 somewhere here. Then y value is 5. Let's say it's 5 somewhere here. And there's a 7, so there's 7 somewhere here. So 3 and 5, you can see it's this point here. And 3 and 7, you can see it's this point there. So you see, if you join the 2 lines, the 2 points, you will have this line. So you can see the line is existing. So it means the line, it is there. This line is there. So now what we have learned here is that when the gradient is undefined, then the equation of the line will be x rather. So the equation of the line will be x equals to c. So we don't actually have to bother about calculating the gradient. All we have to do is to just say, okay, because we have this type of a situation, then we just say, all right, the equation of this line, we look at the points, is the point A and B, so we just take the x value. Can you see in both sides the x value is 3? So we just say, all right, because the x's are the same, so the equation is x equals to 3. So in that case, we will have a vertical line which is parallel to the y-axis, cutting at 3. So we will have this line there. So this is our straight line. So we need to really understand these forms of a straight line. The first one, we said it's the y equals to mx plus c. Let me revise just what I said here. We said it's y equals to mx plus c. In this case, it will cut both the axis. It will cut the x-axis and the y-axis. This is where it's positive. It will cut both the x-axis and the y-axis. This is when it is negative. And then the second one, we said it's the y equals to mx. So in this case, we said it will cut at the origin. So if it's negative, it will be like this. If it's positive, it will be like that. So this is y equals to mx, but you can see they both cut at the origin. And then we said number 3, okay, we said this is number 1, this is number 2, and then number 3 we said it's y equals to c, so it will cut, it will be parallel, this line will be parallel the x-axis, so where depending on the value of c, right? And then the last one that I have talked about, it's x equals to c, so in this case it's parallel to the y-axis, so this is where it's c, so this is our graph. So these are the shapes of our straight line, so we need to understand all these forms. So if it has both the x-axis and the y, the m and the c, then it will cut it. It will cut both the x-axis and the y-axis. But if it does not have a c, it will cut at the origin. And then if it's just y equals to c, it will be parallel to the x-axis. In other words, the gradient is 0. But if it's x equals to 0, it will be actually perpendicular to the y-axis. It will be perpendicular to the y-axis. So in other words, in this case, we will see that the gradient is undefined. Right. So this our 4 forms, or it's actually 1 form, and then all these situations regarding these forms. Right. So that was the form and the equation. So our straight line increases all the way if it's an increasing function. So like this one, it's an increasing function, so it increases all the way. If it's a decreasing function, it decreases all the way. So there is no way where we'll say straight line is increasing and somewhere it is decreasing. So if it is increasing, it's increasing all the way. If it's decreasing, it's decreasing all the way. So in this case, if a straight line is increasing, we also know that the gradient is positive. If it's decreasing, then we know that the gradient is negative. So therefore, we understand now that a straight line can only be, or either be increasing or it can be decreasing. Right, now we are going to look at how to sketch graphs or straight line graph. Right, so there are many methods of sketching a straight line graph. Right, we can look at the intercept method. The intercept method, which is the preferred method of sketching a straight line graph. We have a table method. Now with a table method, we can sketch any graph, be it a trigonometric graph, a parabola graph, hyperbola graph, any graph. We just, in this case, we just put points x and y, and we put points x values, maybe -2, -1, 0, 1, 2, 3, like that, and then we get the corresponding y values, and then we are able to put those points on a Cartesian plane and we sketch the graph. That is the table method. And we also have the gradient intercept method, the gradient intercept method. Right, in this case, just for example, in our equation graph that we talked about, the 2x minus 4, we have the y-intercept as -4, and then we just look at the gradient. The gradient is 2, so we count 2 units, so we have 2 units, 1, 2, and then 2 units, 1 unit for is 2 over 1. If it's 2, it means it's 2 over 1. So 1 unit, we'll just count 1 unit, so it's 2 down, 1 there, and then we will have equation. So so let's see what we have. So we have 2 units. Okay, we go 2 units up, 1 2, and 1 unit to the right, or like that, and then we join this. We have our graph. So that's the gradient intercept method. So right, the method that we said we will prefer to use it because it is faster is the intercept method. So in all our functions, most of the functions that we'll be dealing with, we will be using the intercept method. Now in this case, we only want the intercept. So in other words, we look for the y-intercept, we look for the y-intercept and the x-intercept. Now by intercepts, we want the situation where the graph cuts the axis. So in other words, when we have a Cartesian plane, and the graph is cutting the x-axis here and the y-axis here, so we're only going to calculate those 2 points. So we call these 2 points the intercepts. So this is the x-intercept because it's on the x-axis. This point is the y-intercept because it's on the y-axis. So we are only going to look for these 2 points and then we join them together. So we said these are the x-intercept. Some they call them the y-intercept and the x-intercept. So some they call them the y-cut and the x-cut. Right. So now if we look at this thing of intercept, we realize that on the x-intercept, the y value is 0. So the y is 0 everywhere on the x-axis line. And likewise, on the y-axis line, the x value is 0. So it's very easy because in this case, we only look for 2 points. So the first point is where maybe x is 0, and then we get the y value. And the other point is where y is 0, and then we get the x value. Right. So now, so it becomes easy because if our graph is a graph of 2x minus 4, right? Now, if we start with the first one where x is 0, so we put a 0 here, and then you'll see that 2 times 0 is 0, minus 4 is minus 4. So meaning the y value will be a minus 4. So our first point will be 0 and minus 4, or negative 4. And now the second one, we put a 0 on y and check what is x value. So in this case, we will have a 0 on y, and then we will have the 2x minus 4. You can see when we put the 4 to the other side, so it is going to be positive. So we have 2x. So therefore, if we divide both sides by 2, you see that x is 2. So it means here is 2 and 0. So now it means this point, the x value is 0, the y value is minus 4. And then this point, the x value is 2, the y value is 0, and then we just join the 2 points. So this is the intercept method. I'm not really going to deal with this other methods. We'll just look at this one, and then we will continue from there. So now this is how to sketch the straight line graph. So with other types of forms, I've shown you already how to sketch the line. For example, if maybe we just have y equals to 2x and we want to sketch this graph, already we have indicated that all these type of graphs will cut at the origin. So they will cut at the origin. So what we do is just to get any other point. So we can choose any x value and check its corresponding y value. For example, if x is 1, so we will have 2 times 1. So it means y will be 2. So if x is a 1, y will be 2. So this is the point where they meet. Now it means the graph will just be like that. So we'll just join the 2 points, and then we have our graph. So that is the easier way of sketching the y equals to mx type of a graph. So the x equals to c and the y equals to c, we have already seen how to sketch those when I was explaining the forms there. Right. So now that's how we sketch the graph. Now, the second thing that I want us to do is to calculate the equation. How do we calculate the equation when the graph is drawn for us? Right, so let's look at the graph that we have been dealing with. So now we have this point here to be 0 and minus 4. Here it's 2 and 0. Now here we are given a straight line and we want its equation. So we want to calculate the equation of this line. We don't have the equation, we want to calculate it. Right, so there are a few ways in which we can calculate the equation of this straight line. So the first one is we can use the formula in if the x axis is given and the y axis is given, so we'll just say y divided by the y intercept, if the intercepts are given rather, plus the x divided by the x intercept equals to 1. So remember, this formula works only if the 2 points that are given are the intercepts. So you can easily use that formula. So in other words, we will have y divided by what is the y-intercept? It's minus 4, plus x divided by what is the x-intercept? It's a 2, so equals to 1. Right, so in this case then we can multiply by LCD throughout, which is a negative 4. So if we multiply the y over negative 4 by negative 4, we will get y. So let's just show this. We multiply by negative 4 multiplied by negative 4 multiplied by negative 4. So we'll multiply by negative 4 throughout. So we will have y here. This we will have minus 2x, because 2 into 4 goes 2 times, and then this side will have a negative 4. Right, so we have y equals minus 2x. If we take the 2x to the other side, so we will have y equals to 2x minus 4. You see, we got our equation that we were looking for. So you just say y divided by the y-intercept plus x divided by the x-intercept always equals to 1, and then you work it out, but only if you have the intercept. Right, so if you don't have the intercept, or if you want to use another point, we already know this is the c value, and therefore we can say straightforward that c is negative 4. So in our equation y equals to mx plus c, we can substitute the c, and we can substitute this point here at 2. So the y value there is 0, and we are actually looking for this m, and then the x value is a 2, and then the c is a negative 4. So when we take the 4 to the other side, it will be positive, and then we'll have the 2m dividing by 2 both sides. We will get a 2. 4 divided by 2 it's 2, and this one it's m. So we get m to be 2, and then c is negative 4, and therefore our equation will be y equals to m is a 2x and c is a negative 4. So we can get the gradient like that, the equation like that. So if we don't want to use this method of getting the the m, we can calculate m right away, straightforward, have our 2 points, and then we calculate m. We will still get m to be a 2. Right, so that is how to calculate the equation of a straight line if it's given. Right, so now sometimes we will have a situation where we are given a point, and somehow they hide the gradient somewhere. Somehow they hide the gradient. So there are instances where they hide the gradient. Now, for example, they give you 2 lines which are parallel. They give you 2 straight lines which are parallel. So you have the point of your line, and then the gradient you don't have, but you have the gradient of the other one. So in this case, we need to understand that if the lines are parallel, then they have equal gradients. They have equal gradients. In other words, the gradient for the graph is line number 1 is the same as the gradient for line number 2. So now if the lines are perpendicular, if the lines are perpendicular, then the product of the gradient is -1. So in other words, the gradient number 1 times the gradient of line number 2 will always give us a -1. So this will help us to get the equation, the gradient of the line that we are looking for, if we are given that the two lines are perpendicular. But most of this stuff will be covered when we are doing analytical geometry. But for now, I was just trying to show you that they can hide the gradient behind either parallel lines or perpendicular lines. So if you have the point and the gradient, then you'll be able to calculate the equation of a straight line. You only need to have a point and to have a gradient. Right, so the next thing that I want us to look at is to calculate the domain and the range. The domain and the range of a straight line. Now, to calculate the domain and the range of a straight line, let's remind each other what is a domain. We said that a domain, it's all values of x that are covered or defined on the graph. So values of x which are defined on the graph, the values of x defined on the graph. Right, so we want to know which values of x are defined on the graph. In other words, if we have a graph y equals to mx plus c, so we want the values that we can substitute on x and get the y value, a corresponding y value. Now, if we look at this equation or any other equation, if we put any value of x, as long as it is real, we will be able to calculate for y. We will not get any undefined value there. So in that way, it means that all the values of x, as long as they're real, will do. So we can generalize this as, if they want the gradient of the domain of a straight line, we'll just simply say x covers all real numbers. So x is an element of real numbers. So that's when we want the domain. So if we want the domain, then x will be an element of real numbers. Now the range, likewise, it's now values of y. So if we look at this equation, if we put any value of y, as long as it's real, we will be able to calculate the value of x. So it means, likewise, for the range of any straight line, we will say y, it's an element of all real numbers. So this is the domain and the range of a straight line. Right, so the other things that we will do as we continue, we will actually be looking at things like the transformation. We'll be looking at transformation, but then we will see this transformation when we do other functions. Actually, the next function that we'll be looking at will be the hyperbola. So we will cover the module on transformation there, and we'll see how transformation is done. Otherwise, thank you very much for listening to this lesson. Please don't forget to like, to subscribe. Thank you very much.